May 1969. Phuoc Tuy Province, South Vietnam. Private David Mitchell of 5th Battalion, Royal Australian Regiment, crouches behind a termite mound. 20 meters ahead, a reinforced Viet Cong bunker spits machine gun fire across the clearing. His section commander points at the olive green tube slung across Mitchell's back, 24 inches of fiberglass that weighs less than his rifle. He extends it with a sharp pull. Pop! The weapon telescopes to 35 inches. One shot. No reload. No second chance. The backblast clears vegetation behind him. The rocket streaks forward at 475 feet per second. Silence. Then the bunker erupts. Logs, sandbags, and bodies fly outward in a cloud of red earth. When the smoke settles, the machine gun is quiet. The tube in Mitchell's hands? Already discarded in the mud. Mission complete. Weapon expended. They called it the 66-foot in Australian service. The Americans knew it as the LAW, light anti-tank weapon. But in the jungles of Vietnam, Afghanistan, and Iraq, it became something else entirely. Australia's throwaway rocket that refused to be thrown away. When Australian infantry first deployed to South Vietnam in 1965, they arrived in a tactical nightmare the textbooks hadn't prepared them for. The 1st Battalion, Royal Australian Regiment, inherited a battle space where the rulebook didn't apply. Triple canopy jungle. Monsoon downpours that turned trails into rivers. An enemy who disappeared into tunnel networks before artillery could respond. The Viet Cong and North Vietnamese army had transformed Phuoc Tuy Province into a fortress built from the earth itself. Bunkers constructed from hardwood logs, reinforced with steel, buried under 6 feet of packed clay and camouflaged so thoroughly that patrols walked within meters without detection. These weren't hasty fighting positions. They were engineered killing zones with interlocking fields of fire, often housing 12.7mm heavy machine guns or recoilless rifles. Australian doctrine, inherited from British and American models, relied on combined arms, artillery, air support, armor. But in dense jungle, forward air controllers couldn't see targets. Artillery fell into soft earth without effect. The few Centurion tanks that operated in Phuoc Tuy could barely navigate the terrain, let alone support dismounted infantry in close contact. Between 1965 and 1972, Australian battalions rotated through what became known as the most heavily fortified province in South Vietnam. The 5th and 6th battalions, arriving in 1966 and 1969 respectively, faced a fundamental problem. How does a 9-man section destroy a fortified position when the enemy won't stand and fight in the open? The M79 grenade launcher lacked penetrating power against log and earth construction. The 66mm M31 heat rifle grenade required troops to expose themselves within 75 meters, a death sentence against bunkers with prepared kill zones. The Owen gun and L1A1 rifle fired small arms that ricocheted harmlessly off hardwood. Even the new M16s issued to some units couldn't crack reinforced positions. What Australian infantry needed wasn't a weapon for tank warfare in Europe. They needed portable bunker-busting firepower that could be carried through jungle, deployed instantly, and hit hard enough to collapse engineered fortifications at ranges where small arms were ineffective. They needed something an infantryman could fire without a 2-man team, without assembly, without complex training. They needed what American forces had started issuing in 1963, a weapon so simple it violated every principle of traditional ordnance design. A rocket launcher designed to be used once and abandoned on the battlefield like an empty ration can. The arsenal available to Australian infantry in 1965 represented decades of conventional weapons design, and all of it was inadequate for jungle bunker warfare. The M20 Super Bazooka, a 3.5-inch recoilless weapon left over from Korea, weighed 14.3 pounds. Its 2-piece aluminum construction required a 2-man crew, one to aim, one to load. Effective range, 300 yards against armor, theoretically. In jungle humidity, the electrical firing system corroded. The backblast signature revealed positions. Worst of all, it demanded soldiers carry additional rockets weighing 9 pounds each, weight that infantry couldn't spare when humping through monsoon conditions with 5 days of rations and 200 rounds of ammunition. The M31 heat rifle grenade, launched from the L1A1's muzzle, penetrated 200 millimeters of armor, on paper. Reality, maximum effective range of 75 meters meant grenadiers had to advance into the beaten zone of enemy machine guns. The launch created a distinctive thump that drew immediate fire. Accuracy suffered beyond 50 meters. And firing required soldiers to remember to switch to blank cartridges. Under stress, more than one rifleman fired live rounds with catastrophic results for the rifle's barrel. British 2-inch mortar teams provided indirect fire support, but in thick jungle, observers couldn't adjust fire they couldn't see. The weapon weighed 10 pounds plus ammunition, required a base plate and bipod, and needed clear overhead for the high-angle trajectory. Against bunkers built under jungle canopy, mortars landed in trees or cleared areas away from hardened positions. The Viet Cong, meanwhile, had solved the problem. The RPG-7, entering service in 1961, gave every communist squad a portable, reusable anti-armor capability with 300-meter effective range and 260 millimeters penetration. Simple, reliable, devastatingly effective. Australian after-action reports noted enemy RPG fire with increasing frequency. The technological advantage had shifted. Temperature extremes posed additional challenges. Jungle humidity exceeded 90% during monsoon season. Explosive compounds degraded. Propellant charges absorbed moisture. Metal components corroded despite preservatives. Any solution needed to function in conditions that destroyed conventional ordnance within weeks of field deployment. The tactical requirement emerged clearly from casualty statistics. Australian infantry needed a lightweight, sealed, single-use weapon with penetration exceeding 200 millimeters, effective range of 150 to 200 meters, negligible training requirements, and absolute reliability in tropical conditions. It needed to weigh less than 5 pounds. It needed to be issued one per section, carried without burden, and employed without specialist training. What the Australian Army needed had actually been designed in America 6 years before the first diggers arrived in Vietnam. They just didn't know it yet. The M72 LAW didn't emerge from a crisis or battlefield desperation. It came from a quiet design competition and 3 engineers who understood that simplicity might be revolutionary. In February 1958, the United States Army contacted multiple defense contractors with an unusual request. Design a lightweight anti-tank weapon to replace the M20 Super Bazooka. Primary requirements: individual carry, disposable construction, minimal training, maximum reliability. The Korean War had demonstrated that crew-served weapons were vulnerable in fast-moving combat. Infantry needed personal firepower against armor without depending on specialists. Hesse Eastern Division of Flight Fabrics, Incorporated, a company known for textile manufacturing, not ordnance, submitted a proposal so unconventional that Army Ordnance Board members initially dismissed it as unworkable. A telescoping fiberglass tube. Pre-loaded and sealed. Fire once, throw away. No cleaning. No maintenance. No spare parts. The design team consisted of 3 civilian engineers, Paul V. Choate, Charles B. Weeks, and F.A. Spinale. None were famous weapons designers. Choate, the project lead, had a background in aerospace components. His insight proved critical: treat the launcher not as a reusable weapon system but as packaging for the rocket itself. The tube wasn't a weapon, it was a container that happened to provide launch guidance. Development proceeded at Redstone Arsenal's newly formed Rome and Haas Research Laboratory in 1959. The propulsion challenge came first. The team needed a solid rocket motor with minimal smoke signature, safe storage characteristics, and consistent performance across temperature extremes from -40 degrees Fahrenheit to +140 degrees Fahrenheit. The solution involved a specialized propellant that ignited reliably in any climate and burned clean enough to avoid revealing the firer's position. Once the propulsion system worked, Choate's team designed the launcher around it. 2 concentric tubes, an outer fiberglass shell and an inner aluminum tube, that nested for transport and telescoped for firing. The triggering mechanism, initially the most complex component, went through 17 iterations before the team settled on a simple piezoelectric ignition system. Pull the safety pin. Extend the tube. Press the trigger. 3 steps. A child could understand it. The patent filing in 1963 described the weapon in deliberately modest terms, a lightweight expendable rocket launcher. The Army, recognizing potential, designated it the M72 and ordered field trials. Initial skepticism from traditional ordnance officers evaporated during testing. The weapon functioned flawlessly in Arctic cold and desert heat. Penetration exceeded specifications, over 200 millimeters of rolled homogeneous armor. Weight came in at exactly 5.5 pounds loaded. Length compact enough for paratroopers and mechanized infantry. Most remarkably, troops mastered it in less than 15 minutes of instruction. Production authorization came in early 1963. Tally Industries received the initial contract, with Norwegian company Raufoss securing licensing rights for NATO production. By the time 1st Battalion, deployed to South Vietnam in June 1965, American forces were carrying the M72 into combat. Australian units, still equipped with M20 bazookas and British rifle grenades, watched with interest. The weapon that arrived in Australian hands represented something genuinely new in military technology, not a more powerful weapon, but a simpler one. Elegant engineering disguised as a throwaway tube. And in the bunker-infested jungles of Phuoc Tuy province, simplicity was about to prove itself invaluable. Technical breakdown. The M72 LAW measured 24.8 inches in the closed transport position. Extended for firing, it stretched to exactly 34.67 inches. Total weight, 5.5 pounds with the rocket loaded. For comparison, the L1A1 SLR rifle weighed 9.5 pounds empty. The LAW weighed substantially less than the infantry rifle. Construction utilized two nested tubes. The outer tube, manufactured from reinforced fiberglass composite, measured 66 millimeters in diameter. The inner tube, precision-machined aluminum, contained the rocket motor and warhead assembly. When the operator pulled the rear section, it telescoped smoothly on internal guide rails, locking into place with an audible click. This extension also cocked the firing mechanism automatically, no separate action required. The warhead itself represented the weapon's destructive heart. A 66 mm high-explosive anti-tank-shaped charge weighing exactly 1 kilogram. The conical copper liner, when detonated, formed a superplastic jet traveling at 27,000 feet per second, faster than the Earth orbits the Sun. This jet, though lasting only microseconds, concentrated enough energy to punch through 200 millimeters of rolled homogeneous armor plate or 600 millimeters of reinforced concrete. Penetration physics worked through the Monroe effect, discovered in the 1880s but perfected in shape charge technology during World War II. The standoff distance, the space between warhead nose and target surface, mattered critically. Too close, the jet didn't form properly. Too distant, it dispersed before impact. The M72's nose probe maintained optimal standoff automatically upon impact. The propulsion system burned a specialized solid rocket fuel generating thrust for 0.2 seconds. Muzzle velocity, 475 feet per second. Maximum range, 1,200 meters, though accuracy beyond 200 meters became problematic without optical sights. The rocket stabilized in flight through 6 pop-out fins deploying automatically after leaving the tube. Rotation imparted by canted fin surfaces provided gyroscopic stability. Effective range against bunker targets, 150 to 220 meters. Against moving armor, 170 meters maximum. Minimum arming distance, 10 meters. The rocket safety fuse required that distance to arm the warhead, preventing catastrophic accidents if fired too close to friendly positions. The firing mechanism embodied elegant simplicity. Extending the tube exposed the front and rear sights, flip-up apertures calibrated for 220 meters. A trigger assembly on the upper surface required 8 to 12 pounds of pressure to activate. The piezoelectric igniter, powered by mechanical compression rather than batteries, generated the electrical impulse to detonate the rocket motor. No batteries meant no corrosion, no dead cells, no electrical failures in tropical humidity. Safety features included multiple redundancies. A forward safety pin prevented accidental extension. A trigger safety blocked firing until deliberately pressed. The arming mechanism remained inactive until 10 meters downrange. Even if dropped or struck, The weapon wouldn't detonate without deliberate triggering sequence. Backblast, the weapon's most dangerous characteristic, extended 35 meters behind the firer in a 90-degree cone. The rocket motor expelled hot gas at supersonic velocities, creating an overpressure wave capable of injuring anyone standing behind the operator. Training emphasized checking rear clearance before firing, a lesson learned painfully by more than one inattentive soldier. Temperature tolerance ranged from -40 degrees Fahrenheit to +140 degrees Fahrenheit without performance degradation. The sealed tube protected internal components from moisture, dust, and contamination. Weapons stored in jungle conditions for 18 months fired reliably without maintenance, a feat impossible with crew-served systems. Variants emerged over decades of production. The original M72 A1, issued during Vietnam, featured the basic heat warhead. The M72 A2, introduced in 1970, improved the propellant for reduced smoke. The M72 A3 added a more powerful warhead with 300mm penetration. By the 1990s, the M72 A6 variant, designated for Australian service, incorporated modern explosives and improved sights, extending effective range to 350 meters and penetration to over 450 millimeters. Manufacturing occurred at multiple facilities. Tally Industries, later Nammo Tally Defense Systems, produced American variants. Norwegian company Nammo Raufoss manufactured under license for NATO forces. Australian Defence Force purchased directly from these contractors rather than establishing domestic production, a pragmatic decision given the weapon's complex fabrication requirements. Production cost per unit remained classified, but military procurement documents suggested figures between $800 to $1,200 per launcher in 1970s dollars, inexpensive compared to crew-served systems requiring training, maintenance, and logistical support. The M72 represented reverse innovation. Instead of adding capability through complexity, it achieved effectiveness through radical simplification. One tube, one shot, one job. And in the chaos of jungle combat, that singular focus proved transformative. Now, if you're finding this interesting, consider subscribing. We're building something here for people who actually care about the details, the engineering decisions, the combat reality, the stories that don't make it into official histories. It takes a second, costs nothing, and helps the channel grow. More importantly, it means we can keep digging into the weapons that defined Australian military history. The M72's first combat employment by Australian forces came during 5th Battalion's tour in 1966-67. Official adoption occurred rapidly after American units demonstrated effectiveness. By mid-1967, the weapon appeared in Australian section-level inventories, typically 1 or 2 per rifle section supplementing the traditional arsenal. Private Terry O'Brien, 5R, recorded in his diary after an engagement near Fire Support Base Coral in May 1968, finally got to use the 66 today. VC bunker had us pinned for 20 minutes. Platoon sergeant crawled forward with the tube, extended it, took his time. One shot. Log walls came apart like matchsticks. Yanks were right about this thing, works exactly as advertised. The weapon excelled in situations where conventional arms failed. During Operation Hammersley in August 1968, D Company, 6 RAR, encountered a fortified bunker complex defending a supply cache. Rifle fire and grenades proved ineffective. The company commander, Captain Robert Milligan, ordered forward the section's M72. Corporal James Hughes advanced under covering fire, positioned himself 120 meters from the primary bunker, and fired. The shaped charge penetrated the hardwood and earth construction, detonating stored ammunition inside. The resulting secondary explosion collapsed 3 interconnected bunkers. Hughes's after-action report noted, "Weapon performed flawlessly. Backblast cleared jungle behind me but caused no casualties. Would request additional laws for section inventory." Combat employment revealed unexpected versatility. While designed for anti-armor work, the M72 became the preferred bunker destruction weapon. The heat warhead, though optimized for penetrating steel, proved devastatingly effective against log fortifications. The shaped charge jet drilled through obstacles, then the explosive force behind it generated catastrophic overpressure inside enclosed spaces. Bunker occupants rarely survive the combined effects of penetration, blast wave, and structural collapse. Australian soldiers adapted tactics around the weapon's characteristics. Standard employment: 2-man team, 1 observer with binoculars to mark the target, 1 firer. Unlike the M20 bazooka requiring a loader, the LAW could be operated solo, though buddy system procedures ensured better accuracy and covered backblast safety. Typical engagement distance: 100 to 150 meters, well within effective range but outside enemy small arms dominance. Reliability statistics impressed even skeptical NCOs. Field reports from 1968 to 1971 indicated failure-to-fire rates below 2%, remarkable considering tropical storage conditions that destroyed electronics and corroded conventional ordnance. Sealed tube construction protected internal components from monsoon humidity that rendered rifle grenades and mortar charges unreliable after weeks in the field. The weapon saw action beyond Vietnam in Australian service. During East Timor operations in 1999 to 2000, Interfet forces carried M72 A6 variants. Though heavy armor threats never materialized, the weapons proved valuable for building-clearing operations in Dili. Australian infantry used LAWs to breach fortified positions and destroy ammunition caches. In Afghanistan from 2001 onward, Australian Special Operations Forces and infantry battalions employed upgraded M72 A6 variants against Taliban fortified compounds. The weapon's lightweight, critical in mountainous terrain where soldiers already carried 70-pound loads, made it preferable to heavier anti-armor systems. One SAS trooper interviewed for an oral history project noted, "We carried 2 LAWs per patrol in Uruzgan. Hit a compound wall at 150 meters, the whole section collapses. Fire and maneuver becomes a lot easier when you can eliminate hard cover from distance." Iraq deployments between 2003 and 2009 similarly saw M72 employment, though urban combat placed new demands on the weapon. Australian soldiers firing in built-up areas had to carefully clear backblast zones. The 35-meter rear danger area proved problematic in confined streets. Still, the weapon's ability to defeat reinforced structures made it invaluable during cordon and search operations. Enemy forces developed grudging respect for the M72. North Vietnamese after-action documents captured during the war referenced one-shot disposable rockets as a significant threat to bunker defenses. Unlike RPGs that required visible reloading, the LAW appeared suddenly and disappeared just as quickly. VC units couldn't suppress LAW firers through counterfire because the launch signature gave no sustained target. The weapon failed Australian infantry precisely once in documented combat records. During a 1970 engagement, a 6IR soldier's M72 misfired due to a cracked propellant grain. The rocket ignited but failed to clear the tube, lodging halfway out. Standard procedure called for pointing the weapon safely downrange for 60 seconds to ensure no delayed ignition, then carefully removing the warhead. The soldier followed protocols exactly. No casualties resulted. Tally Industries later issued a bulletin about proper storage procedures to prevent propellant degradation. Tactical doctrine evolved around availability. By 1969, rifle sections in Phuoc Tuy province routinely carried 2 M72s per 9-man section, 1 assigned to the forward scout, 1 to the section second-in-command. This distribution ensured organic bunker-busting capability without depending on attached weapons specialists or external fire support. Psychological impact mattered as much as physical effect. Australian infantry, knowing they possessed reliable bunker destruction capability, approached fortified positions with confidence rather than dread. The weapon transformed jungle warfare from infantry versus fortifications into a manageable tactical problem. Fix the enemy, maneuver into firing position, destroy the bunker, assault through. Simple. Repeatable. Effective. The M72 didn't win the Vietnam War. No weapon could have. But it fundamentally altered how Australian infantry fought in Phuoc Tuy province from 1966 through 1972. Before LAW adoption, Australian doctrine for bunker assault required combined arms coordination, artillery to suppress, armor to breach, infantry to clear. This worked during set-piece operations like Operation Bribie or Coral Balmoral, where planning time and fire support were available. It failed during meeting engagements and patrol ambushes where seconds mattered and radio calls brought artillery minutes later, if at all. The law gave Australian section commanders independent bunker destruction capability without requesting higher-level support. A 9-man section could locate, fix, and destroy fortified positions using organic weapons. This tactical independence accelerated operations. Rather than pausing to coordinate artillery or wait for engineer demolitions, sections dealt with bunkers immediately and maintained momentum. Adoption rates reflected operational utility. By 1968, Australian procurement records show orders for over 8,000 M72 LAW launchers, enough to equip every infantry rifle section with 2 weapons and maintain training stocks. This represented substantial investment for a weapon officially designated expendable. The Australian Defence Force clearly recognised value. Comparative analysis against Allied forces demonstrates Australian enthusiasm for the system. British units operating in Malaysia and Borneo during the confrontation relied heavily on rifle grenades and conventional demolitions. American forces in Vietnam embraced the law enthusiastically, with units often exceeding authorized quantities through informal acquisition. Australian employment patterns mirrored American practices rather than British, pragmatic adoption of effective technology regardless of doctrinal origin. Enemy tactical adaptations provide indirect evidence of the weapon's effectiveness. By 1969, captured North Vietnamese documents advised construction of bunkers with spaced layers, an outer wall of earth and sandbags separated from the inner hardwood logs. This spacing disrupted shape-charge jets, reducing penetration. The fact that enemy engineers redesigned fortifications specifically to counter laws indicates the weapon's battlefield impact. Long-term doctrinal influence extended beyond Vietnam. Post-war Australian infantry organisation incorporated light anti-armour weapons at section level permanently. The concept, every section needs portable bunker destruction capability, became foundational. Even as the M72 itself underwent upgrades, the principle endured: give infantrymen individual firepower against hard targets. The weapon influenced procurement philosophy throughout the Australian Defence Force. The law demonstrated that disposable technology could deliver better operational outcomes than complex reusable systems. This lesson informed later decisions to adopt single-use weapons like the M141 bunker defeat munition and disposable anti-armor systems rather than maintaining expensive crew-served platforms. International military analysts studying Australian operations in Vietnam frequently cited the M72 as an example of appropriate technology matching tactical requirements. Unlike heavy anti-tank missiles designed for European battlefields, the law solved the actual problem Australian infantry faced, destroying fortifications in restricted terrain with minimal logistical footprint. The strategic lesson transcended technology. The M72 succeeded because it simplified a complex problem. Instead of developing elaborate solutions for bunker assault, flame weapons, recoilless rifles, satchel charges, the law provided straightforward capability: point, fire, move on. In military operations where complexity breeds failure, simplicity delivered results. Production and service life. Manufacturing of the M72 occurred across multiple facilities spanning 6 decades. Tally Industries, the original American contractor, produced the weapon at facilities in Arizona beginning in 1963. Initial production focused on M72 LAW variants for U.S. military contracts. By 1966, production scaled to meet Vietnam War demands, with monthly output reaching several thousand units. Norwegian company Nammo Raufoss secured licensing rights in 1964, establishing European production for NATO forces. This facility eventually became the primary manufacturer for international sales, producing M72 variants for over 30 nations including Australia. The Norwegian facility continues M72 production into the 2020s, remarkable longevity for a weapons system introduced in 1963. Australian procurement followed a straightforward pattern: direct purchase from American and Norwegian manufacturers rather than establishing domestic production. Lithgow Small Arms Factory, which manufactured the Owen gun and other infantry weapons, never tooled for M72 production. The decision proved economically sound. Complex composite materials and specialized rocket propellant production made domestic manufacture impractical for Australia's relatively small procurement quantities. Total global production exceeded 2 million units by 1983 when US manufacturing ceased at Tally facilities. Norwegian production continued, with Nammo updating designs to incorporate modern materials and improved explosives. The M72A6 variant adopted by Australia represented fourth-generation technology, enhanced penetration, improved sights, refined propellant, while maintaining the basic operational concept unchanged. Cost per unit remained commercially sensitive information, though military budget documents provide clues. A 2012 US Army contract for M72 variant specified $500 million for approximately 45,000 units, suggesting per unit costs around $11,000 in modern dollars. Inflation adjusted backwards, 1970s procurement likely ran $800 to $1,200 per launcher, expensive compared to rifle grenades but far cheaper than crew-served anti-tank systems requiring training, maintenance, and logistic support. Australian service life extended from 1966 through present day. The weapon deployed to Vietnam, East Timor, Iraq, and Afghanistan continuously from initial adoption through 2014. Current Australian Defence Force infantry includes M72A6 variants designated as the 66mm short-range anti-armour weapon, officially in service with infantry and special operations forces. Quality control during production maintained strict standards. Each launcher underwent functional testing, though naturally not live-fire testing since the weapons were single-use. X-ray inspection verified rocket motor integrity. Pressure testing ensured tube structural integrity. Propellant charges received environmental testing across temperature extremes to verify reliability specifications. Wartime production challenges emerged primarily from propellant manufacturing bottlenecks. The specialized solid rocket fuel required precise chemical formulation and curing processes that limited production scaling. During peak Vietnam War demands in 1968 to 1970, delivery delays occasionally left units awaiting resupply, though Australian forces, with smaller procurement volumes, experienced fewer shortages than American units consuming thousands of launchers monthly. Post-Vietnam service life demonstrated the weapon's enduring utility. Unlike many Vietnam-era systems retired during post-war force reductions, the M72 remained in Australian inventory continuously. Upgrades occurred periodically, improved warheads, refined sights, better environmental sealing, but the fundamental design persisted unchanged. The weapon served through multiple conflicts spanning 5 decades, a testament to original design excellence. Korean War veterans watched it replace the M20 bazooka. Vietnam veterans carried it through jungle campaigns. Gulf War soldiers knew it as a proven system. Afghanistan veterans employed fourth-generation variants incorporating 40 years of incremental improvements. Modern reproduction for collectors remains legally restricted. As a live rocket launcher, civilian ownership faces regulatory prohibition in most jurisdictions including Australia. Museums including the Australian War Memorial hold deactivated examples with inert propellant charges. Collector market prices for properly demilitarized examples range from $500 to $1,500 depending on variant and condition. Surviving combat-used examples exist primarily in military museum collections. The Australian War Memorial maintains M72A1 launchers recovered from Vietnam operations, including examples showing impact damage and field wear. These artifacts provide tangible connection to infantry operations where the weapon proved itself in the worst conditions imaginable. Retirement from Australian service appears distant. Current procurement plans indicate continued M72A6 employment through at least 2030, with potential successor systems under evaluation but not yet selected. After 6 decades, the disposable rocket that was meant to be thrown away continues earning its place in infantry arsenals worldwide. The M72 LAW established a paradigm that dominated anti-armor design for the next 50 years: single-use, individually portable, zero maintenance. This concept, revolutionary in 1963, became orthodoxy. Weapons directly influenced by the M72 include the Soviet RPG-18 Muka, 1972, a nearly identical disposable system adopting the telescoping tube and sealed design. Chinese Type 84 anti-tank rocket copied the form factor while incorporating Soviet warhead technology. Swedish AT-4, entering service in 1987, refined the LAW concept with 84mm caliber and improved sights. The American FGM-148 Javelin, though far more sophisticated, retained the principle of disposable launch tube with sealed missile. Modern military doctrine across NATO and Allied forces assumes section-level anti-armor capability, a direct legacy of LAW employment in Vietnam. Infantry organization charts worldwide include positions for single-soldier-operated anti-tank weapons, a concept that barely existed before 1963. The LAW proved that every rifle section could possess bunker destruction and anti-armor capability without specialist personnel. Doctrinal lessons learned extended beyond hardware. The M72 demonstrated that reliability sometimes matters more than capability. A weapon that works every time is superior to a more powerful weapon that fails when needed. This principle influenced procurement decisions across defense forces globally, prioritizing proven technology over theoretical performance. Design features pioneered in the M72 became standard across disposable weapon systems. Telescoping tubes for compact carry. Piezoelectric ignition eliminating batteries. Sealed construction protecting against environmental degradation. Flip-up sights integrated into the launch tube. These innovations, radical in 1963, now appear in anti-armor weapons from China to Israel to South Korea. Recognition for the original designers remained modest. Paul V Choate, Charles B. Weeks, and F.A. Spinale received no public awards or military decorations. Their patent filed in 1963 described the invention in technical terms without fanfare. Yet their engineering created a weapon system serving military forces across 6 decades and multiple conflicts, a legacy few weapons designers achieve. Modern military historians studying Vietnam-era technology consistently cite the M72 among the war's most successful weapons innovations. While controversial systems like the M16 rifle required years to overcome teething problems, the LAW functioned reliably from first issue. Australian military history volumes, including official accounts of Vietnam operations, reference the weapon regularly, always positively, often credited with saving lives during bunker engagements. The weapon influenced civilian technology indirectly. Telescoping tube construction, pioneered for the LAW, found applications in aerospace systems and industrial equipment. Piezoelectric ignition systems, refined for military rockets, later appeared in automotive spark systems and consumer electronics. Materials science advances in composite tube manufacturing, driven by LAW production demands, contributed to broader industrial applications. Contemporary military analysis reveals continued relevance. Modern threats, fortified buildings in urban warfare, improvised bunkers in counterinsurgency operations, light armored vehicles, remain vulnerable to shape-charge warheads. The M72's fundamental design, though 60 years old, addresses these threats as effectively as it addressed Viet Cong bunkers in 1967. Collector and enthusiast communities maintain interest in the system. Military museums worldwide display M72 examples as representative Cold War technology. Veteran organizations preserve oral histories detailing combat employment. Online forums debate technical specifications and compare variants. The weapon achieved cultural significance within military communities. Soldiers who carried it remember fondly, and that reputation endures. The M72's place in military history stands secure, a revolutionary weapon that didn't look revolutionary. No elaborate fire control systems. No guidance computers. Just an aluminum tube, a shape-charge warhead, and brilliant engineering that made complexity unnecessary. In an era that celebrated technological sophistication, the LAW succeeded through radical simplification. 25 inches of fiberglass. 166mm rocket. A trigger that fired once. This was the weapon that demolished bunkers when artillery couldn't see them. This was the weapon that Australian infantry trusted through 50 years of combat from Vietnam's jungles to Afghanistan's mountains. This was the weapon that proved disposable didn't mean forgettable. The Germans had the Panzerfaust. The Soviets had the RPG-7. The British had rifle grenades and recoilless rifles. Australia adopted the LAW. And when fortifications needed destroying, positions needed breaching, and infantry needed firepower, they could carry themselves without specialist support or logistical nightmares. That simple tube made all the difference. One shot. No second chances. 50 years of proving that sometimes, simplicity is revolutionary.